let f of x equal 4x times e to negative 3x. First, we want to find the relative maximum and minimum values of f. So for that, we have to take the derivative. We need to use a product rule. So the derivative of 4x is 4 times e to negative 3x, plus the derivative of negative e to negative 3x is negative 3 e to negative 3x, and then times 4x. Now I can factor this out. So I have 4 e to negative 3x, and that's just 1 minus 3x. So I factor this out because it's easier to use a number line with, because the thing with 4e to negative 3x, it's an exponential and it's always going to be positive. And so when I find the critical numbers, I can set this equal to 0 and then divide both sides by 4e to negative 3x and get that 1 minus 3x is 0, so x is 1/3. That means the critical point is 1/3, and then we have to test the region here. So pick a point left of 1/3, right of 1/3. So we'll pick 0 and 1. And when I plug it into the derivative, this is positive always. So we only need to focus on 1 minus 3x. If this is positive, then the whole thing's positive. If this is negative, the whole thing's negative. So plug in 0, we get 1. That's positive. Plug in 1, we get a negative 2. So that's negative. That means when the derivative is positive, the function is increasing. The derivative is negative, the function is decreasing. So there's a relative maximum at x equals 1/3. And in order to find what that value is, you have to plug it into the original function. So we're going to do f of 1/3, which is 4/3 e to negative 1, or 4 over 3e. Now, there is no relative minimum because the function never goes from decreasing to increasing. It's only going from increasing to decreasing. Okay, now let's find the inflection points. So for this, we have to take the second derivative. And the nice thing here is that I did leave it in factored form. So let's work with that. So take the derivative 4e to negative 3x first, times the second, plus take the derivative of the second, times 4e to negative 3x. And at this point, I can factor out a negative 12e to negative 3x and be left with 1 minus 3x plus 1, which is just negative 12e to negative 3x, and then 1 plus 1 gives me 2, 2 minus 3x. And now I can set this equal to 0, divide both sides by negative 12e to the negative 3x, and get 2 minus 3x is equal to 0. So x has to equal 2/3. So that's going to go over here for my number line. And now I just need to plug in points to the left of 2/3, say 0, and to the right of 2/3, say 1. So I'm just going to highlight this. This is the second derivative in factored form. This thing is always negative because e is positive, and then we multiply with a negative makes a negative. So if I plug in 0 here, I get a positive number. So negative times a positive is negative. And if I plug in 1, I get a negative, and then this is also a negative. Negative times a negative is a positive. So when the second derivative is negative, this is concave down. And when it's positive, it's concave up. So there's going to be a point of inflection here at x equals 2/3. Okay, next we want to find the interval in which the graph is concave up. So concave up will just be from 2/3 to infinity. We do not want to include 2/3 because the second derivative there is 0. We're only strictly looking at when it's positive. Now we want to find the absolute maximum and minimum values of f. So for that, we have to go back to the first derivative. And notice that the function increases and then decreases. So without looking at concavity, basically it starts off low, goes high, peaks up at x equals 1/3, and then goes down again. So clearly the maximum, the absolute maximum has to be the relative maximum. Now the question is, what is the minimum? The absolute minimum, rather. And for that, you have to look at what's happening at negative and positive infinity. So you have to take the limit of the original function as x approaches positive and negative infinity. So let's do positive infinity first. That's 4x over e to 3x. And for this, you get infinity over infinity. So you can use L'Hopital's rule if you want. But basically, e to 3x wins. In the long run, it's more dominant than 4x. So really, e to the 3x calls the shots when x approaches infinity. And so this is going to be 0. Now when we take the limit as x approaches negative infinity, I'm going to rewrite it as this, just like it was originally, 4x e to negative 3x. Because then it's going to be obvious, because 4x goes to negative infinity, and then e to negative 3x is going to go to positive infinity. So infinity times infinity is infinity, so this will be negative infinity. So what that means is this is going to go all the way down forever. And then as x approaches infinity, it's going to go to 0. So clearly there is no minimum, right? Any minimum you say, I can find find something even smaller. And infinity is not a number, so we cannot say that the absolute minimum is negative infinity. So for that, we're just going to say none. Now, f of x, if f of x is defined on the interval 0 to infinity, find the absolute maximum and minimum values of f. Okay. So for that, we're going to cut this graph here at 0. X equals 0. What's the value at x equals 0? Well, plug in 0 here. I get 0 times 1, so that's 0. So clearly, it goes to 0. So it starts at 0, increases. It reaches at this point x equals 1/3, which is 4 over 3e, and then it goes down to 0 again. So clearly the minimum, the absolute minimum, has to be 0. And that's our answer.